Hello there, ladies and gentlemen. My name's David T. Kramer, and today I'm talking about the greenhouse fallacy. NASA wrote, gases in the atmosphere, such as carbon dioxide, trap heat similar to the glass roof of a greenhouse. Well, what is a greenhouse? What is the troposphere? Are there differences between the two? Impacting temperature? Is an amplifying tropospheric greenhouse effect caused by carbon dioxide actually possible? Well, a greenhouse is a transparent structure used to create a single artificial climate just like the one pictured here. A greenhouse makes use of the sunlight to warm itself and to extend the growing season. The sunlight also provides energy for photosynthesis. Remember learning about photosynthesis in grade school? You know, there are two essential products of photosynthesis. The plants create our food. They take in photons from the sun, create caloric energy for us to eat, and they also produce oxygen for us to breathe. And of course, one of the essential ingredients for photosynthesis is carbon dioxide. In fact, if carbon dioxide goes below 150 parts per million parts, plants will die. And it turns out that all food chains go back to photosynthesis, which means we all die. Oh no! Well, but let's talk about this greenhouse effect. What is it that causes the greenhouse to be warmer inside? Well, three ways in which heat is transferred are radiation, convection, and conduction. Radiation is the transfer of energy by electromagnetic waves of photons. You can sense the effects of electromagnetic waves of energy when in the warmth of the sunlight. Convection is the transfer of heat when warmed molecules become buoyant and rise up while cooler molecules descend. You can sense convection when stepping out of the swimming pool. As the water on your skin evaporates, it becomes buoyant and it removes some of the heat from your skin. Conduction is the transfer of heat through matter. You can sense conduction when touching the hot handle of a pot of boiling water. So now let's put radiation, convection, and conduction together to understand what is this greenhouse effect. Well, because the transparent walls and roof of the greenhouse allow the sun's radiation to heat up the inside. In other words, that those electromagnetic radiation waves come in and they heat up all the matter, all the molecules, the dirt, the plants, and the air molecules are warmed up, but they block the convection of the heat to the outside. Remember, convection, the air molecules move up, and they hit the glass roof. Oh no! Where are they going to go? So the temperature within the greenhouse is hotter than it is outside of the greenhouse. That's the greenhouse effect. Without a continuous source of new energy, the temperature within a greenhouse will eventually become the same as the outside because the glass will conduct energy to the outside. And so during the night, when the sun's radiation is not warming the inside, or if clouds are shading the greenhouse, the conduction of energy through the glass to the outside will lower the temperature inside. Well, what is the troposphere? The troposphere is the lowest layer of the Earth's atmosphere, as illustrated in this diagram. The troposphere is the layer where weather occurs. The troposphere is the layer where all life exists. The troposphere contains the majority of all atmospheric mass. That is, all the molecules in the atmosphere Whether you're looking at the stratosphere, mesosphere, thermosphere, or exosphere, it's 75 to 80% of all the molecules are going to be way down here in the troposphere. As we go up in altitude within the troposphere, temperature decreases. And it decreases because air pressure decreases with altitude. How much does the air pressure decrease with altitude? Well, at the sea level, air pressure is around 1,000 millibars. But on this diagram, if we go to the top of the troposphere, air pressure is around only 225 millibars. And by the way, this little pause, this little space between the troposphere and the stratosphere is called the tropopause. So the top of the troposphere, there is this tropopause. As air pressure decreases with altitude, so does temperature decrease. As illustrated on this graph here, you can see the yellow line. As you go up the line, temperature decreases. The horizontal axis here has temperature in Celsius, and as we move up the troposphere, we move left into colder and colder temperature. The temperature decrease with altitude is immense. Here's some measurements at 180 degrees longitude on November 4th, 2024. If we go above the North Pole, 90 degrees north latitude, the North Pole, the temperature at the tropopause, the top of the troposphere, was negative 89 degrees Fahrenheit. If we go to the tropopause at 60 degrees north latitude, the temperature was negative 74. Above 30 degrees north latitude, the temperature at the tropopause was negative 103 degrees Fahrenheit. And above the equator, at the tropopause, it was negative 116 degrees Fahrenheit. Woo! That's cold. Above 30 degrees south latitude, the temperature at the tropopause was negative 63 degrees Fahrenheit. And on November 4th, at 180 degrees longitude, above 60 degrees latitude, south latitude, that is, the temperature at the tropopause was negative 71 degrees Fahrenheit. And if we go all the way down to the South Pole, the temperature at the tropopause was negative 90 degrees Fahrenheit. So the temperature decrease with altitude is immense. So we go up, up, up to the top of the troposphere. It gets pretty darn cold up there. So we know gravity holds air molecules down, and it increases the air pressure near the surface of the Earth. As we go up in altitude, the air pressure declines, which reduces temperature. A greenhouse is not so tall as to decrease atmospheric air pressure enough to impact temperature. Within the greenhouse, the temperature does not decrease with height, and often the temperature is lowest on the floor because of that little transfer of heat called convection. Within the troposphere, the decrease of air pressure and temperature with altitude exists because gravity exists, whether carbon dioxide is 425 parts per million parts or 5,000 parts per million parts. Let's talk a little bit about radiation and convection within the troposphere. Having been warmed by the sun's radiation, the Earth emits longer wavelengths, lower frequency and lower energy electromagnetic photons known as infrared radiation. Here's a diagram showing the electromagnetic radiation waves, the spectrum of electromagnetic radiation waves, and notice as we move to the left we have shorter wavelengths. They're tighter, closer and closer together, higher frequency, higher energy. And if we go up here to the top, we see that those at the far left are gamma rays, which we cannot see, X-rays, which we cannot see, ultraviolet light, which we cannot see. But then we get into the visible spectrum, because we have photoreceptors on the back of our eyeballs, on the retina, that are triggered by the photons coming in through the eye. There is a spectrum of this electromagnetic radiation that we can actually see. That is the visible light. And if that light reflects off of objects in this band of waves, we will see different colors depending upon the waves that are reflected back. Now, if all of the waves are reflected back, we get white. And if all of the waves in the visible spectrum are absorbed, we get black. So the darker the object, the more radiation that object is absorbing. That's why we don't like to wear a black shirt in the summertime when it's 100 degrees outside. It's a little better to have on white because it will reflect back, that some of that solar radiation, right? Okay. Then as we move farther to the right, notice that from crest to crest of each wave is farther. They get farther and farther apart as we move. If you look at the bottom here, you see that the waves are getting farther apart from each other. So we have longer wavelengths, lower frequency, lower energy, and we move into the infrared spectrum, which we do not see unless you have some infrared binoculars or an infrared camera. And then we microwave and then radio. But the Earth emits radiation in this infrared portion of the spectrum. And a small portion of that infrared radiation causes a tiny fraction, a small fraction, actually less than 1/2 of 1% of the molecules in the troposphere to vibrate. Over 99% of the atmosphere is nitrogen and oxygen, which do not get excited by infrared radiation like does water vapor and carbon dioxide, which are the most abundant of the trace gases that get labeled greenhouse gases. And notice here we have another spectrum going from 1 to 30. These are micrometers. And if you look at the red portion here, each one of these red sections is the tiny, tiny, tiny spectrum of this micrometers of electromagnetic radiation waves in the infrared spectrum. So we're talking about from 1 to 30 infrared spectrum, and only that portion there, around 15 micrometers, you've got quite a bit of excitation of the CO2 molecule, and down between 4 and 5 a little bit, and then down below 3 and around 2, tiny bit. But the point that I want to make here really is that very little of this infrared spectrum excites the carbon dioxide molecule. It's a very, very small amount of the infrared that will excite the carbon dioxide molecule. The vibration of those so-called greenhouse molecules, such as water vapor, carbon dioxide, and methane, does not stop, trap, or block the transfer of heat, as those molecules themselves become buoyant and are further swept up with other warmed air molecules, convecting heat up and away from the Earth's surface. We'll take a look at some mid-latitude cyclones, Hadley cells, Ferrel cells here in a little bit to illustrate that. As the water vapor ascends into colder air, it condenses to form water droplets and clouds. The clouds actually reflect the sun's radiation and thereby shade the Earth's surface. If you've ever seen an image of the Earth from outer space, you notice that the clouds are white. And remember what we said about something that's white. Use your sense of vision. If it's white, it's because it's reflecting back all of the visible light. After reacting to the infrared radiation, a carbon dioxide molecule stops vibrating instantaneously. And according to Google's artificial intelligence, that means it completes one vibrational cycle in about a quadrillionth of a second. That's pretty damn instant. Hence, we can say a small portion of the infrared heat is changed to convected heat for a very short time. The convection continues to transfer heat away from the Earth's surface. The heat is not trapped, whether carbon dioxide is 425 parts per million parts or 5,000 parts per million parts. Let's talk a little bit about water vapor in the troposphere. Together, nitrogen, oxygen, and argon make up around 99.34% of the atmospheric gases. Water vapor and carbon dioxide are the most abundant of the trace gases that have been labeled greenhouse gases. Water vapor is a variable atmospheric trace gas and makes up from near 0% to 0.4%, so less than 0.5%. And you can think about an arid desert climate, compare that with a humid tropical climate, or think about a day when humidity is real high and compare that with a day when humidity is very low. So it's the most variable atmospheric trace gas. Water vapor molecule vibrates for less than a second in response to some wavelengths of the photons in the infrared spectrum, and then it will release a photon, a discrete package of electromagnetic energy, a little photon, in a random direction. Carbon dioxide is also a variable, although it's less variable than water vapor, but it is a variable trace gas, and we don't typically think of it as being variable, but it actually is. Our carbon dioxide is odorless, it's colorless, and absolutely essential for life. The average of carbon dioxide measured in Mauna Loa, Hawaii, is portrayed as the amount in the atmosphere everywhere. And some alarmists propose there is a normal and safe amount for all of Earth's existence. And you can go to 350.org to read about that if you're curious. Out of a parcel of air containing 1 million molecules, think about that. It's hard to imagine a million. It really is. But out of a parcel of air containing 1 million molecules, 423 were found to be carbon dioxide recently in Hawaii. Geological data indicate carbon dioxide was as much as 5,000 parts per million parts 500 million years ago. A carbon dioxide molecule will vibrate for less than a second, and if you believe Google AI, a quadrillionth of a second, who can imagine something that short, in response to some wavelengths, that little short sections of red on that graph I showed you, of photons in the infrared spectrum, and then release the photon in a random direction. So imagine 360 degrees, that photon can go out anywhere, up, down, sideways. It gets released in a random direction. So really what happens is these greenhouse gases have a redirecting effect upon some of the electromagnetic radiation in the infrared spectrum. So we have a redirecting effect of some of these trace gases. because some of the infrared radiation emitted by the Earth's surface excites some of the trace gases, and because those trace gases then randomly release some photons back in the direction of the Earth, and because those photons are assumed to potentially warm the Earth, they are called greenhouse gases. And tables have been created with numbers indicating what is called a global warming potential of the various so-called greenhouse gases. Around 50% of the incoming solar radiation, and this is the part that everybody seems to forget, that around 50% of incoming solar radiation is also infrared, and it excites the very same trace gases, which then release some photons, once again in a random direction, but some of those will get released in the direction of outer space. Consequently, the same gases reduce the amount of sun's infrared radiation reaching the Earth's surface, and thereby they reduce the warming of the Earth by redirecting some infrared energy away from the Earth's surface. So the Earth is warmed less, it has less infrared radiation to emit itself because it is warmed less as a result of those so-called greenhouse gases. Hence, the global warming potential numbers also represent an Earth cooling potential, and so by the very same logic, they cancel out the global warming numbers. Here's a table. The net effect of gases, 100-year global warming potentials from the IPCC fourth assessment report, combined with those gases' 100-year Earth cooling potentials. So if we look at carbon dioxide, it's given a 1. That's the baseline. Methane is 25 times the 1. Nitrous oxide is 265 times the 1. Sulfur hexafluoride is 22,800 times the 1. So the IPCC says that the global warming potential over 100 years is 22,800 times the carbon dioxide if it's sulfur hexafluoride. But because the sun's infrared radiation also excites those gases, and because some of that radiation is going to be directed back into outer space, the same gases have the same Earth cooling potential. So methane has 25 times the 1 carbon dioxide cooling potential, and so we can subtract those out and we get a net effect in 100 years of 0. Ooh, hey, I got an idea. Let's just say we've already achieved net 0, right? Man, we could save a lot of money if everybody would agree with that. Well, if we go to Mauna Loa Observatory in Hawaii, we find NOAA measuring the parts per million of carbon dioxide in the atmosphere. And notice here that this graph, and you can find thousands and thousands of these. If you Google this, you will find, I guarantee you, thousands of this images of this graph made very similar to this one here. And what I want to indicate to you here is that this image really is misleading. It is one of the things I learned at the university was to think critically about the way people present their data, okay? If you're doing research and somebody presents data to you, take a look at how it's presented. Look, they're starting the y-axis at about 315 parts per million. And then the top of the graph goes up to 420 parts per million. Well, that creates a very misleading image of what's going on here with these parts per million parts being measured in Hawaii. The data image really exaggerates the amount. You know, the image creates a perception. The managerial class, I'm going to say, is intentionally leading us astray. The managerial class is intentionally misleading the public with this kind of graph. And you see it over and over. You have to search a long time to find one like this that starts with 0, and it gives a little bit different image of the increase from 1960, 1959, 1960 up to, in this case, on this graph, 2020. But it's the exact same data, but it's plotted to a 0 scale. And so, even though we can say, though, even though carbon dioxide has increased, it has increased, and no doubt it's increased because we are using fossil fuels, especially oil, gas, and natural gas and coal. It has been increasing, but it's not increased as much as it appears in the other graph. It's not as dramatic, we could say. But even though it has increased, when we look at the typology of climates upon Earth, they're still the same. So we keep hearing this climate change. Oh my God, it's climate change. We're all going to die. But with this addition of some carbon dioxide, the typology that was created back in 1884 by a guy named Köppen is still valid. So as we look inside of our troposphere, we see that we have multiple climates. So unlike the climate of a greenhouse, which has a single climate, the troposphere contains many climates. And on this image here, on this graphic, those climates are illustrated with colors. Now, Köppen developed this typology back in 1884, and it's still valid today. And in Köppen's typology, which is very valid, there are 5 main climate groups: tropical, arid, temperate, continental, and polar, with 31 subgroups. Think about that, 31 subgroups of climates. So we have no single global climate. We have 31 climates. And actually, when you get down into those, you can even see differences. I can see differences between the southeastern part of my state and out here in the central part where I live. And there's no single global temperature either. Within the troposphere, there's a decrease in temperature as latitude increases. So as we go from 0 degrees to 90 degrees north, where the North Pole is, or 0 degrees to 90 degrees south, where the South Pole is, we notice that the temperature decreases as we increase the latitude. And that's because the angle of the incoming solar radiation is different as we move toward the poles. When we go near the equator at 0 degrees latitude, the sun's radiation is more direct, and it's spread over a smaller area than at the higher latitudes. The amount of solar radiation at 0 degrees latitude on a clear day without clouds is around 1,000 watts per square meter. As we move on the surface toward the poles, the solar radiation is less direct and spread over a larger area of surface. For example, at 80 degrees latitude, on a clear day, without clouds, the amount of solar radiation is only around 100 watts per square meter. So it's only 10% of the wattage at the equator. Carbon dioxide does not, will not, cannot change the angle of the sun's radiation. However, there was a Serbian named Milankovitch who spent years with many, many mathematical equations figuring out what are called the Milankovitch cycles. And if you want to know about how the angle of the sun's radiation changes on scales of tens of thousands of years, take a look at the Milankovitch cycles. This graphic illustrates how the angle of the sunlight changes depending upon how close you are to the poles or how close you are to the equator. So at the equator, more direct, then the angle becomes lower as we move towards the poles. Spread out farther over a larger area. So the temperature decrease in the polar regions is immense. The coldest temperature ever recorded was negative 128.6 degrees Fahrenheit in Antarctica. The coldest temperature recorded in the Arctic was negative 93.3 degrees Fahrenheit in Greenland. The average during the winter at the North Pole is negative 40 degrees Fahrenheit. The average temperature during the winter at the South Pole is negative 76 degrees Fahrenheit. So, the polar regions are kept cold by the low angle of the sun's radiation. The polar regions are further kept cold by 6 months of zero sunlight. The polar regions are also kept cold by the white snow and white ice on the polar caps, which reflect nearly 100% of the visible solar radiation. Prevailing patterns of atmospheric circulation ensure heat is never trapped, as air is continuously cooled when moving upward in altitude toward the tropopause and moving upward in latitude toward the polar regions. Here we have a graphic showing that the sun warms the earth most directly around the equator, which leads to warm air molecules becoming buoyant. And so they move up in the troposphere. And as they move up, they leave a void. The void left by the air molecules moving upward pulls surface level air from the northern and southern hemispheres into a low pressure zone around the equator known as the intertropical convergence zone. And you see that red arrow on the surface moving towards that area, and then the air going up and up into the higher altitudes toward the tropopause. The buoyant intertropical convergence zone air is cooled as it ascends to the top of the troposphere. The air molecules then diverge at the top of the troposphere at the tropopause, with some of the air moving northward and some moving southward. At around 30 degrees latitude, there's a high pressure zone where the cooled air moves downward to the Earth's surface. When the air reaches the surface, it diverges northward and southward, as some of the air is again pulled toward the equator and some of the air is pulled toward the 60-degree latitude low pressure zone. The air is cooled as it rises again to the top of the troposphere at around 60 degrees latitude and again diverges northward and southward. At around 30 degrees latitude, the air descends again to the surface where it again diverges. At the poles, there's a high pressure and the air molecules descend to the surface and are pulled toward the 60-degree low pressure zone. The fact is, heat is never trapped. And under the second law of thermodynamics, Hot air is continuously releasing energy when moving up in latitude toward the poles and up in altitude toward the tropopause. Turns out we don't actually live in a greenhouse. This is an image from NOAA's Deep Space Climate Observatory. It's about 1 million miles away from the Earth, and it always shows the sunlit side of the Earth. And what I want to show you here are some comma-shaped images, circulation patterns in the atmosphere. And these are known as mid-latitude cyclones. And these mid-latitude cyclones are bringing cold air to the lower latitudes and taking warm air to the higher latitudes. And because these comma-shaped cyclones are revolving around a low pressure, they are also taking air upward to higher altitudes. Here's an image of the United States on October 29, 2024. And here we have warm air moving up from the Gulf and cold air coming down. So we have two air masses here. This is the predicted highs on the same day, October 29. And the reds indicate higher temperatures. Most of these are in the 80s, the mid-80s. And the greens and the blues are indicating colder temperatures. So you have this cold air mass coming down and this warm air mass moving up and cooling as it goes up in latitude and as it revolves around the low pressures that sort of lined up along here at this time, taking the air up higher in altitude where it cools as well. So we have to take a look at this global pattern of circulation and everything that we've just talked about. And we read gases in the atmosphere such as carbon dioxide trap heat, similar to the glass roof of a greenhouse. We've got to say this is really pretty not true. It's basically false, that statement. NASA also wrote that increased water vapor in the atmosphere amplifies the warming caused by the other greenhouses. Well, where does water vapor come from? Well, it comes from evaporation, right? So you can sense the temperature changes on your skin as you move in and out of the shade provided by clouds on a partly cloudy day. So to get clouds, you got to have evaporation. And those clouds reflect the sun's radiation. Around 71% of the Earth's surface is covered by water, and water evaporates as a result of the sun's radiation. This is why my mom used to hang the clothes out on the clothesline. Allow that electromagnetic radiation wave from the sun to heat the moisture in the clothes, and then that moisture would evaporate, become buoyant, and leave the clothing, and it would dry. Evaporation removes heat energy from the surface of the oceans. Clouds develop as the water vapor ascends into the atmosphere and condenses. As more and more of the Earth's surface is shaded by clouds, surface temperatures are further reduced, and consequently, guess what? Less water is evaporated. And of course, as less water is evaporated, fewer clouds are formed, and consequently surface temperatures increase as more of the sun's radiation is not reflected by the clouds. The formation of clouds and the dissipation of clouds modulate the amount of heat on the Earth's surface. And this is what John Clauser, Nobel-winning physicist, calls a cloud thermostat. Here's again that image And by the way, I'd encourage everyone to go to Discover Epic and take a look at these images. It's really a fascinating thing, this deep space climate observatory that's always taking images of the sunlit side of the Earth. This image was taken on 9/11/2024, and I believe this thing right here, right there, entering into the United States, you can probably pick it out there. That is, I believe it's Hurricane Helene, if my memory is right here. But in any case, this image is showing the clouds modulating the surface of level heating. And there was a cool study done going back over, I don't know, a number of years. This study was done, and I referenced it down here at the bottom of the slide. You can go look at it and read it for yourself if you want to. But I took a little quote from that study, and the scientists who did this say it's remarkable that the behavior over ocean shows a clear convex function with changes of almost 50% in cloud fraction within a day. So maybe we're starting out the day at 10% cloud coverage, and we may go all the way up to 60%, and we may go back down to 10%. And typically that's about what happens on a daily basis, is that the cloud fraction will change a great deal. So the formation and dissipation of clouds, as we said a while ago, modulate surface level heat. And that's going to happen no matter whether carbon dioxide is 280 parts per million or 5,000 parts per million. That's going to happen. So NASA wrote increased water vapor in the atmosphere amplifies the warming caused by other greenhouse gases. Well, if you take into consideration the modulating effect of the temperature on the surface, we're going to have to pretty much determine that statement's just not quite exactly right. I think we're going to have to say that's pretty false too. Unlike the fixed roof of a greenhouse, the height of the troposphere expands and contracts. It has nearly doubled at times as measured in Pyron, Switzerland, changing from less than 8,000 meters, around 5 miles high, to nearly 16,000 meters high, or around 10 miles high. And here's a graph produced by the radio sounding instruments there at Pyron, looking at the height of the tropopause. And this study here, this data here represents about 29 years of radio soundings. And you can see here that at one point the troposphere was all the way down to a little less than 8,000 meters. And at one point it was a little less than 16,000 meters high. So the troposphere expands and contracts. It expands vertically and contracts during all seasons, but expands more during the warmer months. Buoyant molecules move heat up from the Earth's surface into colder, less dense air, and each molecule releases energy in the process. Now, alarmists claim that the entire atmosphere is warmed because carbon dioxide elevates the level at which infrared radiation is emitted to outer space. But I'm claiming with this presentation that the alarmists are ignoring the flexibility of the troposphere. They are ignoring the true power of the clouds to reflect the sun's energy. They are ignoring the prevailing patterns of atmospheric circulation. And they are ignoring the power of carbon dioxide to redirect the sun's infrared radiation. And that's why their models are so far off. The true climatologist models are so far off when it comes to being able to predict the temperatures that they are using in their models. So, modern civilization was built and is sustained with fossilized energy. And remember, it's fossil fuels, coal, oil, natural gas, that release carbon dioxide into the atmosphere. Of course, you can look at the carbon cycle. It comes from many places, but this is a thing we get propagandized all the time that fossil fuels are evil and carbon dioxide is evil and they're terrible, it's awful, we're going to have climate change, oh my God, it's a terrible thing. Coal was the primary source of energy for industrialization by the time we get to 1900, and we had a population on Earth of 1.6 billion people. And notice the coal here in the gray, by 1900 is the primary source of energy for this 1.6 billion people, especially in Europe and the United States, where the most industrialization was going on at that time. Of course, now industrialization is moving out across the globe. Everybody wants to industrialize. Everybody has been industrializing. And so by the time we get to 2019, coal, oil, and natural gas are providing 80% of our energy, and we have about a 7.7 billion population. But we've also had, several decades of spending trillions and trillions of dollars on these very short-lived, very contaminating, environmentally contaminating, and very unreliable, because the wind doesn't always blow and the sun doesn't always shine and the angle of the sun changes with the seasons and the clouds, and it's just unreliable energy. We're trying to build a whole new infrastructure, a whole new culture based on these short-lived, contaminating, and unreliable wind and solar, and they call them farms, but they're not farms. But despite spending trillions and building these things all over, fossil fuels continue to increase to 81% of energy used in 2023 with a population of 8.2 billion people. Oil is the fossil fuel that we use the most. Here's an old graphic that shows that in fact the majority of our material goods, I would say including electric vehicles and solar farms and wind farms, the majority of our material goods, the majority of our material culture contains derivatives of oil. And the majority of our everyday activities, whether we're working, maybe we're driving a semi-truck that's diesel powered, or we're driving a train that is diesel powered, or maybe we're driving a cargo ship that is diesel powered, or we're just driving to work. The vast majority of our transportation is done through some type of combustion engines. Communication, look at your cell phone. Cooking, just about everything that we do involves products that were developed with fossil fuels and were designed for use with fossil fuels and depend upon energy produced by fossil fuels. So I'm going to make the argument that fossil fuels are really the keystone of our society, our modern society. And we've got some really good news that was published in Nature Climate Change, April 25, 2016. A quarter to a half of Earth's vegetated lands has shown significant greening over the last 35 years, largely due to rising levels of atmospheric carbon dioxide. And in the study, they talk about this is because of the increased use of oil, natural gas, and coal. With the use of satellite data, an international team of scientists determined there was an increase of leaves on all types of plants, including crops and trees, amounting to an area twice the size of the United States. So we can say, not only is fossilized energy the keystone of modern civilization, if you pull that keystone out, civilization is going to collapse. But its use has added 7.5 million additional square miles of leaves, producing food for us to eat, for our cows to eat. You know, whether you eat, maybe you're a carnivore and you only eat meat, fish, fowl, eggs, and dairy. Those food sources go back to photosynthesis. The cow eats the grass, you eat the cow. So we've got 7.5 million additional square miles of leaves because carbon dioxide is like fuel. The plants breathe in carbon dioxide, they breathe out oxygen for us 8.2 billion people here on the planet Earth. So, a tropospheric amplifying greenhouse effect caused by carbon dioxide is false. The trace gases, which react to the Earth's infrared radiation, are actually vehicles of convection which transfer heat up and away from the Earth's surface into colder, less dense air. Unless you can change gravity, that's going to happen. As you move up in altitude, the air is going to get colder. Carbon dioxide neither traps nor generates additional heat. It is essential for photosynthesis, which produces our food and oxygen. Carbon dioxide is not a pollutant. It's a clear, odorless gas that's essential for life. You've got to go way, way up in concentration before it becomes a problem in terms of breathing. Clouds resulting from evaporation and convection modulate the sun's radiation. The use of the term greenhouse gases is misleading in the context of the troposphere and is used to manipulate you and I, the public, by institutional managers. Western nations are wasting trillions of dollars in natural resources, labor, power, and technology to combat a non-existent problem. In the process, officials are increasing our debt, inflating our prices. Look at the price of concrete to build a house. And, go back and look at the historical graphs of the price of concrete and lay that on top of the historical production of wind farms and how many tons and tons of concrete are poured into the ground to produce this unreliable energy from a wind generator. So, one of the reasons houses have inflated in price is because we're taking the natural resources for this to combat a non-existent problem. We're increasing taxation, increasing the price of energy, and transferring wealth to a small number of elites who fly around in their jets and go to these meetings, global meetings, and make plans to control our carbon footprints, right? We're moving more and more to a totalitarian situation. But these same elites do not make any of the sacrifices that are forced upon you and I. A Treasury report indicates the federal government has accumulated $142 trillion in debt and liabilities. Most of those liabilities are unfunded. Some politicians claim they can simply raise the taxes on billionaires and solve the fiscal problem that they themselves created. Yet the total wealth amassed by all Americans of every economic class, I'm talking billionaires, millionaires, upper middle class millionaires, lower middle class, upper lower class, lower class, all of the wealth that we Americans have accumulated amounts to only $152 trillion, according to the Federal Reserve. So that means the Republicans and Democrats have already obligated 93% of our wealth. And foolishly, in 2022, Congress chose to add another $400 billion in debt to reduce carbon dioxide and combat this mythical problem known as the greenhouse effect. Here's 6 points I think are worth remembering. An amplifying greenhouse effect is not applicable to the atmosphere. Heat is never trapped in the atmosphere because it is continuously transferred by prevailing patterns of atmospheric circulation. Water vapor produces clouds which modulate the sun's heating of the earth. Global increases in carbon dioxide increase the global production of food, yum, yum, yummy, and oxygen that we all need. And fossil fuels are the keystone of modern civilization. Pull that out, modern civilization will collapse. If these nutballs, these alarmists, are successful with their net zero stuff, our civilization will collapse. We cannot afford to continue diminishing everyone's wealth because the managerial class's greenhouse fallacy. It is a fallacy, and that's all I got for y'all today.